All right, welcome to lecture 12, part B. So in this lecture, we're going to keep working with this idea called the mole and start linking it to some other topics that you heard about in the past. So let's go ahead and get started. Okay, so to see how moles relate to other ideas, we actually need to go back to the periodic table. So you might remember in the last set of videos, we talked about this number underneath the symbol, like for example, for iron. And remember it says like 55.85 there. And what I told you in lecture 11, I guess it was that when you look at that number, like for iron, that is the weight of an iron atom. So 55.85 is the weight of one atom of iron. Now, what was the unit? 55.85 AMU. That is the weight of one atom. One little tiny atom of iron. Couldn't even see the thing. That's how much it weighs, 55.85 AMU. Or if we do another example, maybe we'll do boron. Like for boron, the weight of one atom of boron is 10.81. One atom of boron weighs 10.81 AMU. All right. So these numbers on the periodic table, they tell you the weight of one atom. But there's another way to interpret them, okay? So what we're going to do now is we're going to use the same number, it turns out, but we can use it in a different way. The scale, the periodic table, has been set up to tell you two things at once. It tells you the weight of one little teeny tiny atom. You couldn't even see it. For iron, it weighs 55 AMU. 55.85 AMU. But it turns out, if I have a mole of iron, that's a huge number of iron atoms, right? What is a mole? It's 6.02 times 10 to the 23 atoms. If I have this ginormous collection of atoms, billions and billions of atoms, which we call a mole, the weight of all of those atoms together, it still would weigh 55.85, but not AMU, 55.85 grams. So the number on the periodic table, it tells you two things at once. How much one single atom weighs. The units on that are AMU. But it's also been set up so that if you want to know how much do all of these atoms weigh together, a mole of them, their combined weight, it weighs 55.85 grams. Same number, but a different unit. So, like, same thing is true for boron. If I have a mole of boron, what does that mean? A whole lot of boron atoms. Billions and billions of them. 6.02 times 10 to the 23 atoms of boron. Their weight together, they would weigh 10.81. 10.81, same number, but a different unit. 10.81 grams. So the periodic table actually is going to give us conversion factors to go between a mole of something, a ginormous number of atoms, and how much a mole weighs in grams. A mole of iron weighs 55.85 grams. A mole of boron weighs 10.81 grams. So we can use that as conversion factors to go between moles and weight, grams and moles. All right, so we're going to do a few examples of this. So weight is related to moles, grams are related to moles by using the number underneath the symbol. All right, so let's kind of sum this up and then we'll get to some examples. Let me flip over here. Okay, before we get to that example, actually, let me kind of sum up what we've been doing. All right, so last video, part A, we did problems like this. We went from moles to particles. So the way you go between moles and particles, you saw this in part A, 6.02 times 10 to the 23 of something, we call it a mole. Now, those somethings are different kinds of particles. They could be atoms, if we're talking about an element. They could be molecules, if we're talking about a molecular compound, or they could be formula units, if we're talking about an ionic compound. So one of those three words you're going to stick in this box here. Depends on what kind of substance we're talking about. 6.02 times 10 to the 23 of something is a mole. Atoms or molecules or formula units. That was the last video. Now what we're seeing in this video is moles is related to grams. It's related to weight as well. So the way it's related to weight is moles and grams are related by that number on the periodic table. So whatever number you see on the periodic table under the element, that's how many grams it takes to have a mole. So this conversion will get us between grams and moles or vice versa. You use the weight off the periodic table. All right, so we're going to do a couple where we're trying to get between grams and moles, or maybe the other way around. So let's see how you can do that. All right, so it says in this one, if I have 88 grams of iron, how many moles of iron do I have? 88 grams of iron, how many moles of iron do I have? So what I'm going to do first is I'm going to write down my beginning number and unit. I'm going to write down what I'm solving for. Now this time they want me to go to moles. Now the way you go from grams to moles, it has nothing to do with that Avogadro's number. The way you go from grams to moles is we're going to have to use the weight off the periodic table. And the number I see underneath iron, a little hard to read there, is 55.85. So 55.85, whatever it says on the periodic table, I promise this is always true. The number on the periodic table is always how many grams it takes to have 1 mole. So next to the number off the periodic table, the unit that goes with that number, the 55.85, the unit that goes with that number is grams. 55.85 grams is 1 mole. So again, this part is going to be the same. The only thing that would be different if I asked you about carbon or nitrogen or something else, the number would change, right? You'd use the number underneath those elements instead. All right, so with that, let's see if we can get it done. 88 grams of iron, how many moles is that? Now, we haven't done one like this at all, but if you're using your units, you know what to do. I'm not even going to tell you. You tell me. If you start off with grams, what do you guys want to do? Multiply or divide by 55? Look at your units. I hope you decided to divide. So you would put grams on the bottom. That makes the 55.85 go on the bottom and the 1 mole go on the top. So the units are telling me, hey, I got to divide. Because if grams are here, we're going to put grams here to cancel. That makes the 55 go on bottom. So you got to divide. If you work it out, you should get an answer of 1.58. All right. All right. Let's try another one. Let's try another one. Let me flip over. Let's try another one. Okay. So one more example along these lines. Okay. In my wedding ring, there are 0.0510 moles of platinum. All right. So this is my wedding ring. I don't know if, man, that's kind of warm. So I don't know if it'll come off. Oh, there it goes. Yeah. So this is a platinum wedding ring. This is what I get when I got married. Okay. So in this wedding ring, when my wife gave it to me, I said, you have to tell me what you're handing me. And she said, here you go, honey. I am handing you 0.0150 moles of platinum. How romantic. 0.0510 moles of platinum. And then I said, well, if that's how much platinum you're giving me, I wonder how many grams you're giving me. How much is this wedding ring weighing? How many grams does it weigh? All right, so I know how many moles are in this ring. How many grams does it weigh? All right, so how do you do that? Oh, the way you do it is the periodic table. Let's find platinum. It says right here is platinum. 109 is, I know it's tiny. It says right underneath platinum, it says 150, let me read it, 159.08. 159.08. Now, 159.08. What unit always goes, when we're doing a converting problem like this, what unit always goes next to the number off the periodic table. What unit? What unit is going to belong right here? Oh, I hope you know it was grams. 159.08 grams. It's always going to say grams next to that number equals 1 mole. And now you got a conversion factor. So this part again stays the same. The only thing that changes is the number. Depends on what thing we're talking about. This time we're talking about platinum, so it's 195.08. All right, so with that, I think we're in business to convert, right? So we're going to write down our beginning number unit. Oh, yeah. We're going to write down the thing I'm trying to get to, grams. All right. And how are they connected? The way they're connected is that number off the periodic table. So now we should be able to use it. The 195.08. So let's look at our units. Moles are here. So to make moles cancel, you have to put it on the bottom of the next step. All right. What number is going to go on the bottom? What number is going to go on the bottom? 1. Look at your conversion factor. 1. And then the 195 has to go on top. 195.08. Should look like that. All right. So, does that work? I think so, because moles cancels, and we're left with grams. All right. So if you work it out, you basically got to multiply this time. 0.0510 times 195.08. We're multiplying. And if you work it out, you can try it on your calculator. When I did it, I got about 9.95 would be the number of grams, 9.95. I think I rounded right? Because this number had 3 sig figs. And then I think when I wrote the 9.95, yeah, that has 3 as well. All right, so grams to moles, moles to grams, periodic table. Periodic table is how you go back and forth between those. All right, let's try one slightly different. Let me move over to it. Okay, actually, before we get to another one, I need to remind you one thing from the last lecture, lecture 11. So in that last part of lecture 11, I guess part C, remember there was this part where I was adding up the weights off the periodic table to figure out the entire weight of a molecule. And so, like, for example, I think we did water, and when I added up 2 hydrogens and an oxygen, we got 18.016, all right? Now, again, that was the weight of 1 molecule of water. All right, that was the weight of 1 molecule of water. And 1 molecule of water weighs 18.016 AMU. That is the weight of 1 molecule. Now, and we did another one too, didn't we? We did carbon dioxide, 1 molecule. Kind of miswrote it there. There we go. All right, so we also did carbon dioxide while we're at it, right? We added up a carbon and 2 oxygens. It added up to 44. And again, 44.01. And that was the weight in AMU for 1 molecule. This is the weight of 1 molecule of carbon dioxide. 1 molecule. All right. Now, let me mention one last thing. Do you remember what we called this when we added this up? It had a name. It was called the formula masses. These are formula masses. Formula masses, and maybe I'll just write over the periodic table here, is the mass of 1 molecule of something. 1 molecule of something. So we added up hydrogens and oxygens, and we got whatever, 18 and 44. Now, in this chapter, we're going to not talk about the weight of 1 molecule. Kind of similar to what I was mentioning a few minutes ago for elements. The number underneath the symbol tells you the weight of something, 1 something in AMU, but it also tells you the weight of a mole. So kind of like we did with atoms, if I want to know the weight of a mole of water, it's going to weigh 18, but 18, kind of like we did with the elements, 18 grams. So, oh, I meant to switch to another color. So 18 grams, 18.016 grams to be exact, is the weight of a mole. Just like we did with the elements examples a minute ago. So the number off the periodic table you get, now if it's a compound, you have to add them together. But the weight you get off the periodic table, that is how many grams it takes to have a mole. So that part is always true. For water, it was 18. For carbon dioxide, yeah, one little lousy carbon dioxide molecule weighs 44.01 AMU. A mole of water, so that's a bazillion carbon dioxide molecules. I guess we could write it out. 6.02 times 10 to the 23 of them, molecules of them. That is the weight of a mole, I should say, that weighs 44.01 grams. So the number off the periodic table, it tells me the weight of a molecule, but also tells me the weight of a mole. A huge collection of molecules. So we can use these as conversion factors to go from grams to moles, kind of like we did with an element a minute ago. Now, there's only one other thing that I don't want to trip you up on. When we talk about the weight of a mole, instead of calling it a formula mass, we call it a molar mass. So a molar mass, it's the same number. It's the 44 for carbon dioxide. But if we're thinking in terms of moles, it's called a molar mass. A molar mass is the mass of 1 mole of a compound. All of those molecules put together, if they're carbon dioxide, they're going to weigh 44 grams. 6.02 times 10 to the 23 water molecules, a mole of water is going to weigh 18 grams. So again, you can interpret the number two ways. If you're thinking in terms of AMU, that's the weight of one fella. If you're thinking in terms of grams, all of them together weigh 18 grams. All right, so with that, let's do an example. Okay, let's try another one. So this one here, let's see. It says, if a glass of water contains 55.5 moles of water, how many grams of water are in the glass? If a glass of water contains 55 moles of water, how many grams of water are in the glass? All right, so now that we're kind of introducing more ideas, sometimes people get mixed up on like, what am I supposed to be using? All right, so I think that diagram, I put it up on the top there. I hope it's going to help you out. So if we are starting off with moles, a glass of water contains 51.5 moles of water. We're starting here. And I am trying to go to grams. If you're trying to go from grams to moles, the way that those ideas are linked again is the periodic table. So we're not going to be using Avogadro's number. I left out a decimal here. 6.02 times 10 to the 23. All we need to do, all we have to use is the periodic table. All right. So you're going to have to know, when do I use the periodic table? When do I use Avogadro's number? Moles to grams, that's the periodic table. All right, so let me go ahead and write down the number I'm given. All right, we're converting 51.5 moles of water. And that is, I want to know how many grams of water. How many grams of water? So the conversion factor, again, is the weight off the periodic table. Now, we added it up a minute ago. I'm not going to go through and add it up. You can rewind if you want and look. It was 18.016. So when you add up two hydrogens and an oxygen, you got 18.016. 18.016 grams is 1 mole. So that weight off the periodic table next to that number always goes grams. All right, so let's see how we're going to use it. Well, why don't you think about it? Do you want to multiply by 18 or divide by 18? What do you guys want to do? Multiply by 18 or divide by 18? I think you should be multiplying. 1 mole would go on the bottom. The 18 goes on top. It should look like that. Now, if you work it out, and I worked it out earlier, what did I get? I got 929 grams. 929 grams. All right. We're going to try one or two more. Okay, so beginning part of this lecture. What did we do? We did a bunch of problems like this. Moles to molecules, moles to atoms, moles to formula notes. We did a bunch like that, right? In part B of this lecture, we've been doing this. Moles to grams, grams to moles, vice versa, right there, right? All right, let's do the grand finale for this lecture. For my final performance, we are going to do one where we start off all the way over here with grams, and if we know the weight of something, Let's see how many things are inside of that something. So let's do one where maybe we have to combine all of this together. Let's see if we can do it. I think we can. All right, let me move over and we'll try it. Okay, so for our last example in this video, let's do one where we have to do maybe a little more work. All right, so I tell you like you have 0.334 grams of carbon dioxide. So carbon dioxide, as you're sitting here watching this video, that's what you're exhaling, right? So let's say you exhaled 3.44 grams of carbon dioxide, and that's actually about how much comes out of your mouth every time you breathe. 0.344 grams of CO2. So this is again what carbon dioxide looks like, right? A carbon and two oxygens. And what I want to know is if that's the weight of the CO2 that's coming out of my mouth as I sit here and breathe, how many actual little molecules am I exhaling? How many of these guys are coming out of my mouth? All right. So I know the weight of the CO2. How many of these things am I exhaling? How many of these guys? So this is going to take a little more work, and I'll tell you why. Because you're starting off knowing the grams of carbon dioxide. I want to know how many molecules of carbon dioxide. Now we're saying molecules, right, because it's a molecular compound, so we're not going to say atoms or formula units. So the reason this is going to take a little more work is I'm going to have to convert from grams to moles first, and then I'm going to need to keep going, and I'm going to go from moles to molecules next. So it's going to take two steps. This is a two-step problem. So grams to moles, that means we're going to be using our periodic table. Once we use our periodic table to get to moles, then we're going to have to use Mr. Avogadro's number to get to molecules. All right, so let's try it out. Let's see how we do. All right, so I'm going to write down my beginning number and unit. 0.344 grams of carbon dioxide. Then I'm going to write where I'm trying to go. Molecules of carbon dioxide. And looking at this map up above, looking at the little guide that's helping me, I realize it's going to take me two steps. All right, I'm going to need two steps to get this done. Grams to moles first. We're going to do grams to moles first. That means we're going to use our periodic table first. Now, in the interest of not boring you to death, we already added up the weight off the periodic table for carbon dioxide. It was a carbon and two oxygens. And when I added up a carbon and two oxygens, I added it up to 44.01. And what was that? Oh, the number on the periodic table, 44.01. That's how many grams it takes to have a mole. So the weight off the periodic table, remember, always what do you write next to it? You write grams. 44.01 grams is a mole. Now what are we going to do next? We're going to figure out how to use it, right? So we have grams to start with. Yeah, we have grams to start with. So I need grams to cancel out. Where does the 44 go? It should go on bottom, right? So you put the 44 on the bottom because you need grams on the bottom. So this side's going to be on the bottom. The 1 mole goes on top. It should look like that. All right, so I think we're in pretty good shape as far as getting the first step done. Grams are gone. Now we have moles. But I don't want to stop now. I need to keep going. I'm going to go from grams to molecules. So now grams to molecules, we're going to need to use Avogadro's number. All right, now let's remember how that works. Avogadro's number is 6.02 times 10 to the 23 is a mole. Oh, wait a minute. How'd that work from the beginning of this class? 6.02 times 10 to the 23 is a mole. 6.02 times 10 to the 23 is a mole. 6.02 times 10 to the 23. What word am I missing there? 6.02 times 10 to the 23. Not atoms, not formula. Molecules is a mole. All right. So you should have the word molecules there. Now with that, I think we're in business. Let's see where we're at. We have moles right here on top. So I'm going to put moles on the bottom. It makes the 1 go on the bottom and the 6.02 times 10 to the 23 go on top. And that should work. That should work. All right. So with that, I think we have it set up right. Yeah, because moles is going to cancel. And now we're with molecules. All right, so let's see if you can work it out. So you're typing your calculator, and I did it earlier. So it'd be 0.344 times 1, doesn't really matter, times 6.02 times 10 to the 23. That definitely matters. Divided by 44.01. Try it out. Make sure you can know how to do this in your calculator. It's not always so easy. You should be getting 4.70 times 10 to the 21 is what I came up with. So that's how many of these guys you would be exhaling every time you take a breath. All right, I hope this makes sense. We're going to practice in our Zoom sessions too, because usually it can be a little confusing. We'll do some a little different, but along these same lines, okay? So if you're stuck, of course, you can email me. Otherwise, I guess that'll be it for lecture number 12. I'll see you soon. Bye-bye. Oh, there's going to be a couple pop-up questions I forgot. Wait. There you go. Hopefully you got them. I'll see you next time.